Hello dear students, welcome to our YouTube channel Diksha Karnataka. So in today's video, we will be discussing the solutions of mock test 3. The question paper for this mock test is available in our WhatsApp channel and it is also available in the description of this video. Okay. So in this video, we will be discussing the part 1, okay, for first 30 questions of this mock test. So out of 60 questions, this will be consisting of first 30 questions. So let us solve them. So the first question is the pair of species having the same percentage of carbon, right? So we all of you know what is the formula to calculate the percentage, right? The percentage of the carbon, or you can say percentage will be equal to mass of the carbon divided by the total mass, right, into 100. But you see, this question has so many options, right? And every option has different compounds. So it will take a lot of time to calculate the mass percentage of every carbon. So there is a trick for this. How to solve this one? You can just see the empirical formula, right? Those compounds whose empirical formula is same, in that case the percentage of carbon will be same. So now for example, you see the first option here, this option and this option, the empirical formulas are different. So we can rule out this option. Now if you see second option, this compound can be written as C2H4O2 and this compound can be written as C2H6O, right? Again, they will have different empirical formula, so we can remove this option also. Now let us see the third option. If you see here, we can write C2H4O2 and this one we can write it out C6H12O6. So you can see both of their empirical formula will be CH2O. So when the empirical formula will be same, we can say that their percentage of carbon will be same. So answer for this question will be your option C. So generally we get a lot of questions on empirical formulas from the first chapter, and so it is an indirect application of empirical formula, right? So please prepare empirical formula properly. So now this is very easy question. Let us go to the next question. So this question has come from your chapter structure of atom, quantum numbers. Okay, so it is very important topic, Bohr's theory and quantum numbers. So let us just revise the range of all the numbers. N, if n is principal quantum number, we have the next one, L will lie from 0 to n minus 1 and ml will lie from minus L to plus L, right? So these are the values we have. So now you can just see if n is equal to 3, L can be 2, that is correct. If n is equal to 4, n can be 0, that is correct. This is 5, this is 2, this is also correct. But now check option D. So if n is equal to 3, L values possible are 0, 1 and 2. It cannot be 3, right? So that is why this is an impossible arrangement. So answer for this question will be option D. Again, very easy question. So and from this chapter, focus on quantum numbers and Bohr's theory. Okay. So these two are very, very important topic. Now, okay, so there is a small but important announcement for all of you. We have a KCET crash course just immediately after your board exams are over. In this crash course, the whole syllabus of both PU1 and PU2 will be completed in 28 days and you will be getting proper mock test revision. So to get more details on this, you can see the WhatsApp channel and you can enroll in and register in this program. Okay, so this will be a definite help for your exam. Okay, now coming to third question. Which of the following statements is correct? So ionization enthalpy of magnesium is less than that of sodium and aluminium. So this question is again from your periodic classification. Okay, important chapter. So let us first arrange these elements given. Okay, so we have sodium, then we will have magnesium, and the last element in this will be aluminium. Along a period, what happens? Along a period, the ionization enthalpy increases, right? So that is why if you see ionization enthalpy of magnesium will be less than aluminium, but it will be greater than sodium. But this statement, that is why, is wrong. Coming to the second statement, atomic radius of F is more than oxygen. So what is the, again F is there, oxygen is there. So along a period, what happens? The size decreases, right? So the atomic radius of F will be less than that of oxygen. So this statement is also incorrect. Now negative electron gain enthalpy of fluorine is less than that of oxygen. As we know, along a period what happens? The negative electron gain enthalpy increases. So the electron gain enthalpy of fluorine is more than that of oxygen. So that is why this statement is also incorrect. Now coming to this one, beryllium, boron and carbon. See this one, beryllium, boron and carbon. So let us look at their electronic configuration. So this is 1s2, 2s2. Here it is 1s2, 2s2, 2p1. And for carbon it is 1s2, 2s2 and 2p2, right? So if we remove electron, right? So you see from boron, electron can be easily removed because after one electron is removed, we are getting a stable electronic configuration. But in case of beryllium, we have to remove from a fully filled orbital, and in case of carbon, that doesn't make any difference. So that is why among beryllium, boron and carbon, boron has the lowest ionization enthalpy. Along the period, if you see that concept, if you apply, carbon should have the beryllium should have the lowest, but here again electronic configuration is also an important point, right? So the correct answer for this is option D. Okay, now let us move to the next question. Okay, formal charge. This question comes from chemical bonding. So two important topics, Vesper theory and formal charges, you have to prepare from this chapter. Simple formula based question. What is the formula for a formal charge? Valence electrons minus non-bonding electrons minus half of bonding electrons, right? So let us put for oxygen, we have total valence electron for oxygen is 6, right? Minus how many non-bonding electrons you can see here? 2, 2, 2. So total it is 6 minus, it is forming one bond. This bond contains 2 electrons. So number of bonding electrons is 2. So half of 2 electrons. So we will get the charge here minus 1. So you can see two options are having, all these three options are having minus 1. We can rule out this option. Now let us see for the second oxygen. It is again 6 minus, we have how many non-bonding electrons? 4 minus half of the total number of bonding electrons here are 4, right? 2 bonds are there, here 2 electrons and here 2 electrons. So if we solve this, we'll get 0, right? So the correct answer for this one will be B. This is very simple formula based direct question. Okay. Next, a gaseous mixture was prepared by taking equal moles of carbon monoxide and nitrogen. Of the total pressure of the mixture was found to be 1 atm. So these two data are very important. They are given you equal moles, right? So let it be X, right? Let the moles of carbon monoxide be X and the moles of N2 be X. So now what will be the mole fraction of CO? 1 by 2, like X by 2X, that is 1 by 2, and mole fraction of N2 will be also 1 by 2. And what we have to calculate? You have to calculate the partial pressure. So what's the formula of partial pressure? Partial pressure is mole fraction of the gas into P total, right? So mole fraction is 1 by 2 and P total is 1 atm. So we will get 0.5 atm, right? So this is also a very simple one. Question from your solutions chapter, partial pressure calculation. Okay, so now we can go to the next question. For which of the following delta S is not positive? So this question is from thermo topic, right? So such questions are very common. You have to just calculate, you have to just see where the entropy is increasing. So entropy is not increasing, it is not positive, okay? So that means it should be negative, right? Delta S should be negative. Okay, now let us see the first option, solid to gas. So we should know the order of entropy, solid, liquid and gas, right? So when it goes from solid to liquid, gaseous products are formed. So here entropy is positive. This cannot be the answer. Now see the option, this one. Here you see in the reactant side, there is one gaseous reactant. But on the product side, there is no gaseous reactant, right? So that means what? The entropy has decreased. So this is where the entropy is negative. This can be the answer. Let us check the other options. Here you see 2 gaseous molecules are there, 3 gaseous molecules are there. Number of gaseous molecules are increasing, so entropy will be positive here. Now coming to this one. Here you see solid is there and in the product side we have a gaseous product. So when solid to gas we are moving, again entropy will be positive here. So these two also cannot be the answer. The answer has to be option B, right? So this topic, very easy question comes. You can focus on the work formula and such type of conditions for spontaneity, and this entropy should be positive, negative. Such questions you can focus on. Okay, now again another question from Thermo. The heat of combustion of carbon is given to us, this one. The heat released for the formation of 22 gram of CO2. Again, very simple question. What is the meaning of heat of combustion? Means when carbon was combusted, we got CO2. During this process, the energy released was 393.5 kilojoule, right? So this is per mole, right? So that means, can I say when 44 gram of CO2, when 44 gram of CO2 was produced, at that time the energy released was 393.5, right? Now it is asking for 22 gram, right? That is half of this. 22 gram is half of this. So half of this will be minus 196.75 kilojoule per mole, right? So this is your option D. Clear? So just you see, we are decreasing by half. So the energy release will also be decreased by half. So such thermochemistry based questions, you have to be a little careful. Hess's law and such questions are generally asked in the exam. Okay, now going to the next question. Precipitate. Okay, this is from your equilibrium concept. Okay, equilibrium concept, the question is the precipitate of calcium fluoride, KSP, is given to you, is obtained when equal volumes of the following mixtures are mixed. The mixture which gives the precipitate. So to start this question, first and the foremost point you should know is what is the condition for precipitation. So the ionic product should be greater than the solubility product, right? Ionic product should be greater than the solubility product. This is the condition. Now just what is the ionic product of CaF2? Ionic product of CF2 will be Ca2 plus concentration into F2 minus square, right? So now let us check the values for option A. How much we'll get? 10 to the power of minus 4 here and twice here. So we will get 10 to the power of minus 12, right? Then you see this is less than your KSP value. Second option you can see, here we'll get minus 3, twice it is 6, and here it is minus 2, minus 8 I'll get. This can be the answer because here ionic product is greater than the solubility product. Third one you can see, minus 5 is there, and then again 6 will get 10 to the power of minus 11. So that is also less than your KSP value. Third one, minus 5, and here it will be minus 15, right? So you can see in all these options, in option B, the ionic product will be greater than the solubility product. So in that case, precipitation will form. So the precipitation will happen in this option B of the solution mixture. So this is also very simple concept and one of the important concept. Okay, now let us go to the next question. Okay, this is again from equilibrium part, chemical equilibrium part. We have been given with 3 reactions. Their Ka values are given and they have asked us the correct relation. Okay, now you see how this reaction would have been obtained. You can see if we add the first 2 reactions, HS minus will be get cancelled. H plus and H plus will be added to give you 2H plus. This S2 minus is present here and this H2S is there. So when these 2 reactions are added, the third reaction is obtained. So that is why when the reactions are added, their equilibrium constants are multiplied. So we will have K3 is equal to K1 into K2. Option A will be correct. So 2 more relations you should remember here, very important part. If a reaction is reversed, then what happens? The K value also becomes 1 by K, right? And one more thing, if you multiply a reaction with n factor, the whole reaction is multiplied with n, then K equilibrium becomes K to the power of n, right? So these 2 formulas also you should know. So this is also easy question based on chemical equilibrium. So this chapter has little, from the first PU has more weightage. So prepare all these formulas from this chapter and your Kp, Kc relation, that all things also you should know. Okay. Okay, next is again, this question is from your redox reaction. Simple question. What is the oxidation state of chlorine here? So if we calculate X minus 2 is equal to minus 1, so chlorine is plus 1 here, and here X minus 6 is equal to minus 1, chlorine is plus 5 here, and if you see here it is minus 1. So plus 1 to plus 5 is oxidation, again plus 1 to minus 1 is reduction. So in that case, this is your same element undergoing oxidation and reduction. It is a disproportionation reaction, a direct definition based question, right? Easy to score. Okay, let's see the next question. Okay, IUPAC name. So first rule for IUPAC name is what? This is again from your general organic chemistry. You can see every topic has one question in this. So we should first find the longest carbon chain. So you have 4 carbons here, 5, 6, 7, 8. So the name, the parent name should be from octane. You can see only one option has octane. Heptane will not be correct, heptane will not be correct, and butane will not be there. So directly you can mark it. Again, we can check the options here. So if we start naming here 1, 2, 3. Okay, this will be 4. On the 4th carbon, we have 2 substituents. So 3, 4, 4, trimethyl octane. Right? Again, very simple nomenclature based question. Right? Nomenclature. So you should know functional groups, how to name, how to prioritize the functional groups. That all things should be revised. Okay. Okay, this is very tricky question from your first chapter, basic concepts of chemistry. Some basic concepts of chemistry. Number of atoms in 52U. Okay, 52U of helium. So what is this one? Atomic mass unit, right? We know one helium atom is 4 AMU, right? That means how many atoms will be there? 52 by 4, that will be your 13 atoms. If the question would have been 52 grams, then we should multiply with Avogadro number, right? We'll first convert it into moles and then we will convert it into number of atoms. But here the unit is AMU, so already its answer should be 13. Many students might have gone for option B, but that is incorrect. Had the question would have been 52 gram, then we could have divided by 4 gram per mole and we would have got here 13 moles. And then we multiply with Avogadro number, right? But see here the unit is 52U, okay? So that is why do not get confused here, tricky question. So we have to be little careful here, okay? But simple one. Next question. Total number of isomeric alcohols with the molecular formula of C4H9OH, right? So let us draw first how to derive it. Try to make the carbon of different number of chains, right? Like for example, in the first C4, I will make them in one chain. In here, in this position, I can attach OH here. This will be 1. And in another isomer, I can attach OH here, right? This is butane 1OL and this is butane 2OL. So with this linear chain of 4 carbons, I can have 2 such isomers. Now let us change the number of carbon and make it a 3 carbon chain. Right? So here you can attach OH here. So whether attaching OH on these 3 positions, these all are same. So that will give you one more isomer. Another position special is this one. If we attach a OH here, right? So total number of isomeric alcohols we can get is 4 for this answer, question, right? So now let us move to the next question. Okay. In Dumas method, 0.3 gram of organic compound. Okay, so this question, Dumas method, is from your basic principles and techniques, right? Basic principles and techniques of organic chemistry. So in Dumas method, 0.3 gram of an organic compound gave 41.9 ml of nitrogen at STP. The percentage of nitrogen is. So now let us write down the formula. Percentage of nitrogen will be 28, that is the molar mass of nitrogen, divided by the volume 22,400 ml, right, into the volume produced at STP 41.9 ml divided by the mass of organic compound taken 0.3 gram into 100, right? So if you solve this, we will be getting around 17.37%, right? So this is again a direct formula based question. So you can calculate. Similarly, the Zeldal method formulas also you should know. Calculation of hydrogen, carbon, those all, what is the percentage, how to calculate it. Those formulas you can revise it. Okay, next question. Which of the following is most reactive towards sodium? Again a question from GOC. Okay. most reactive towards hydrogen means the sodium, the compound should be highly acidic, right? The H should be highly acidic. And we know ethyne is highly acidic here, the H produced, because we have here other groups which can destabilize the conjugate base formed. So in this answer, the CH group, the H from the alkyne part, ethyne will be very stable one. So it will be more reactive. Okay. Next question, let us move. Okay, reaction sequence. Okay, again, this is from your hydrocarbon chapter. In the following sequence of reaction, the end product is. So let us see, this is the method of preparation of ethyne, right? So we will get C2H2. Now if you add Hg2 plus, that is your mercuration and demercuration, we will get ethanol here, right? After that, after getting ethanol, if we oxidize it, any aldehydes on oxidation will give us acetic acid, right? Then when we further treat with this calcium hydroxide, I'll get a salt of this one, CH3COO whole 2 Ca, right? Now when we treat it again with heat, right? After treating with calcium hydroxide, we have to heat it. So there will be decarboxylation and we will be getting the compound acetone, right? So this is a reaction based question. Many such questions come where you have to revise the reaction sequence. You should know all the reagents required, revise the reagents properly, all name reactions thoroughly, right? So this is again a simple question. Let us go to the next question. Which of the following is not a conductor of electricity? From electrochemistry, right? Our direct question, we know all electrolytes will conduct electricity in the either in the aqueous form or in the molten form, right? So solid NaCl is a non-conductor of electricity. Easy question, direct question. Next, for an ideal binary liquid mixture, okay, the question is from solutions chapter, ideal and non-ideal solutions. So we know for ideal solutions, delta H mix is 0. This part is correct, but delta X mix is less than 0. This is not correct. Next question, delta entropy of mixing is always positive, right? Entropy will always increase. So delta S of mix is greater than 0. That is correct. Delta G of mixing is a spontaneous process. So delta G of mix is less than 0. This part is also correct. Delta S mix 0, this is wrong. This is also wrong. V mix is equal to 0 is correct. This one is wrong. So our correct answer will be option B. So let us just revise the all the conditions here. Delta H mix, delta V mix is equal to 0 for ideal solutions. Okay. Delta S should be greater than 0 and delta G should be less than 0. So because it is a spontaneous process. Okay. In spontaneous process, what happens? Entropy should increase and your Gibbs free energy should decrease. Right. So answer should be option B. Little I'll tell conceptual question. Not direct. It's formulas are given, but still it is little conceptual question. Next, molar elevation constant, again from solutions chapter. This type of question is directly formula based. Right. What is it is asking? Molar elevation constant is the ratio of elevation in boiling point to. So first of all, we should know the formula for this. This is a colligative property, right? Elevation in boiling point, delta TB is equal to KB into M, right? So now what they are asking you, KB will be equal to the ratio of elevation in boiling point to. So KB will be equal to delta TB by M, right? So it is the ratio is M is your molality here. So answer is molality. Again, very easy question and a direct question. Next, a plan. Again, this question is from solutions. So as we have discussed already, solutions is a chapter with very high weightage. You can already see in 3-4 questions have been asked. So properly revise this chapter, easy to score, and you will have some theory based questions and some numericals also. A plant cell shrinks when placed in. So there will be hypertonic solution. You know osmosis. This part is from osmosis. Okay. So when it is placed in a hypertonic solution, you can see here cell is there, and outside if you placed a hypertonic solution, then what will happen? Water from the cell will come outside, and this cell will again shrink and will become shorter in size, right? So this is osmosis, correct answer. Okay, now 2 moles, again you see this question is from solution. So you can see so many questions are asked from this chapter. Please revise it thoroughly. 2 moles of a non-volatile solute are dissolved in 5 moles of water. So let us write down this data. 2 moles of a non-volatile solute dissolved in 5 moles of water, right? So what is the number of moles of solute? 2. Number of moles of solvent is 5. Okay, next, vapor pressure of the solute relative to that of the water. Here the trick lies. Okay, so we know whenever we add a non-volatile solute to any solvent, the vapor pressure is decreased, right? That is also a colligative property, that is your relative lowering of vapor pressure. What's the formula for that? P naught minus P by P naught is equal to XB, right? So we can calculate here XB. XB will be 2 by total number of moles, that is 7. But is the question asking that to us? Read the question properly. The question is asking the vapor pressure of the solute relative to that of the water. Means we need the ratio of P by P naught, right? So how can we obtain that? So this equation can we arrange like this? 1 minus P by P naught is equal to XB, that is your 2 by 7, right? Then what will be P by P naught here? P by P naught will be 1 by 2 by 7, and the answer will be 5 by 7, right? You can see here 2 by 7 is also given us. So that can be a confusing option, but you have to read the question. Had the question been what is the relative lowering of vapor pressure, the answer is 2 by 7. But they are asking the relation between the pressure of the solution to that of the pure water, right? So that is why the answer should be 5 by 7. Okay, this one question is little tricky, not difficult, but the language of the question is little tricky. Next, okay, again we are going to our next chapter, that is your electrochemistry. This is again, this part is from your commercial cells. In the dry cell, what is the anode, right? So we have certain this nickel cadmium cell, mercury cell. So practice the anode. What is anode is made up of what? Cathode is made up of what? So that revision you have to do. Now what is it given here? Anode is your zinc container. Okay, so let us also discuss what is the cathode made up of. Cathode is made up of carbon and manganese oxide, right? So please remember, other cells also you should revise. So this is again direct question and easy one. I hope all will be getting correct in these questions. Okay, now see the next question is also from electrochemistry. Which topic? Nernst equation, right? So EMF of the cell at 25 degrees Celsius is given to us. We have to calculate at 25 degrees Celsius. The cell is made up of copper and silver, right? So as we have already discussed many times, the left part is for oxidation. The right part is for reduction. So let us write the reaction for both of them. So oxidation will take place at anode, right? So what is the reaction at anode? Anode reaction will be copper giving rise to copper 2 plus 2 electron, right? What will be the reaction at cathode? Cathode will be Ag plus will gain 1 electron. Ag plus will gain 1 electron to give you Ag, right? But one thing we have to remember here is the number of electrons should be same. So multiply the second equation with 2 and then we can add it. So what we will get? Cu plus 2Ag plus is giving me Cu2 plus 2Ag, right? This is the final equation we'll get, right? So now what is the Nernst equation? Nernst equation formula is E of the cell will be equal to E naught of the cell minus 0.059 by 2 log of what is there on the product side? Copper plus concentration of copper plus divided by concentration of Ag plus Here people do mistake, they forget to take the coefficient as power, right? So that is why it is very, very important that you write the reaction. So Ag plus is having a coefficient of 2, so the power here will be 2. Now you check the concentration. What is copper concentration given? 0.01. And what is Ag plus concentration given? 0.1. And that has to be taken square. 0.01 by 0.1 square. So you can see this term will get cancelled, right? So if this term get cancelled, the whole term will become, this part of will become 0, right? Then what we have to only calculate, so we can say E of the cell is equal to E naught of the cell. Now let us calculate E naught of the cell. Very simple, cathode minus anode. So this is my cathode, this is my anode. So what is silver electrode potential? 0.8, and copper electrode potential is 0.34. So we have to just take 0.80 minus 0.34. So how much I'll get? 0.46 volt, right? So again, Nernst equation is very important topic from electrochemistry chapter. You have to revise it properly. But this numerical is a simple one, right? So what is the answer? 0.46. One more thing what you can do is, you can also eliminate option B and D very easily. We know this is our equation, right? So E of the cell will come less than the E naught of the cell. E naught of the cell is 0.46, so it cannot be 1.14 and 1.29. So option B and D can be easily eliminated. The answer can be either option A or either option C, right? Next question. Again, the next question is from electrochemistry, Faraday part. The quantity of electricity needed to separate the electrolyte of 1 mole ZnSO4, aluminum chloride and silver nitrate will be in the ratio of. This is again simple. You have to just check the charges of this one. Zn charge is Zn2 plus, aluminum charge is 3 plus, silver charge is plus 1, right? So to reduce this, we need 2 moles or 2 Faraday of electron, we need 3 Faraday of electron, and here we need 1 Faraday of electron. So the ratio will be, the quantity of electricity will be 2:3:1, right? Again, this is very easy question and can be scored easily, right? Nothing very deep is there. Next question. Okay, now the question has come from your chemical kinetics. What is the activation energy for a reaction if its rate doubles when the temperature is raised from 300 to 310 Kelvin, right? And the rate doubles. These two are important points. Now, this question is from which concept? Arrhenius equation, right? So, very important concept. Let us write, you must revise the formula. Log of K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 into T2, right? So we have this K2 and K1. What is the value? You can see the rate doubles, right? That means rate constant will also double. So we can write this value will be log of, suppose if K1 is equal to X, then K2 will be equal to 2X, double of that. So if I take a ratio of this one, K2 by K1, the ratio will come to log of, then EA we have to calculate 2.303 into R value is 8.314. T2 is your 310 Kelvin. 300 Kelvin divided by 300 into 310. T1 into T2. This is 310. Okay. So now if we solve this, the calculation part is little lengthy. You have to calculate it. If you solve this, you will get the answer around 53.5. Okay. So please check it up by solving. It should come 53.5 kilojoule per mole. Direct formula based question. Again, this question is a direct one. Formula based question, right? So from chemical kinetics, you'll be getting questions from 0th order, 1st order, those part. And Arrhenius equation, this question is also important for your board exams and is also there in your competitive exams. Okay. Next, the time required, again this is a kinetics question, chemical kinetics question. The time required for 100% completion of a 0 order reaction. Time required 100% completion means the reactant has completely converted to products. First of all, we should know the integrated rate law of a zeroth order reaction. Generally, we are more familiar with the first order reaction integrated law, right? Zeroth order, also you should remember A naught minus A is equal to KT, right? What is the question asked here? Time required to complete for the 100% completion means what? The final concentration has become 0. Whatever initially you have taken, what is A naught here? Initial concentration, A is the final concentration, right? So the final concentration has become 0. So what is the value of T then? A naught by K, right? So here A initial concentration is taken as small a by K. So we will get option C. So I can say this question is easy, but generally we do not focus on zeroth order reaction. We generally do more number of questions with first order reaction. So this question becomes important. This formula becomes important, right? Next one. Again the question is from chemical kinetics. First order reaction is half completed in first order reaction. The first data that you have to take in mind, half completed. This is very, very important data. That is your half-life is given 45 minutes. How long does it take for 99% of the reaction to be completed? So this is a relation that we derive many times, that is T99.9 is equal to 10 times of T50. Right? This relation, if you do not remember, you will end up in doing the long process and that will consume a lot of time. So you have to remember T99.9 is equal to 10 times of T 50%. So what is my T 50%? 45 minutes. So I can write T99.9 is equal to 10 times of 45 minutes. Right? So that will be 450 minutes. But you can see the options are in hours. So to convert them to hour, we have to just divide by 60. We will get 7.5 hours. Okay. So the answer is option D. So this is again a formula based question. Formula, but we are generally not much aware of this formula. So please keep in note, this formula is important. Okay. And it will save a lot of time. Next question. Aluminium is more reactive than iron, but aluminium is less easily corroded than iron, because again a question from electrochemistry, redox reaction part, corrosion part. So we all know oxygen forms aluminium is a noble metal. That is wrong. Oxygen forms a protective oxide layer on aluminium surface. Yes, this is correct. When aluminium is there and it reacts with the oxygen, a protective layer of aluminium oxide is formed on it, because of which it prevents the further corrosion, right? So answer will be option B. Iron undergoes reaction easily with water. Not correct. Iron forms both divalent and trivalent. This statement is correct, but it is nowhere related to the question asked. Okay. Fe can exist in Fe2 plus and can also exist in Fe3 plus. But that doesn't depend on why it has no relation with aluminium. So this option is also incorrect. Okay. So this is again a very fact-based question. Okay. Next one. The quantity of electricity required to liberate 112 centimeter cube of hydrogen at STP from acidulated water is. This is a question from electrochemistry and a very, very important question. How to solve such type of questions? We should know some basic things about this. First of all, we should know 1 Faraday will deposit or will release 1 equivalent volume. Okay, it is not 1 molar volume, 1 equivalent volume. 1 equivalent volume you have to remember for certain things. H2 equivalent volume is, okay, what is the formula of equivalent volume? Let me first tell you, molar volume by N factor, right? So what is our molar volume? 22.4 liter. For H2 the N factor is 2, right? Because 2H plus will gain 2 electrons, will get 11.2 liter. So now let us first solve this question, then we will discuss some other equivalent volumes from where also question can be asked. So I can say for depositing 11.2 liter, 1 Faraday is required, correct? Then for depositing 1 liter, it will be 1 by 11.2 Faraday. Now question is asking for 112 ml. For that much, how much we read? 1 by 11.2, this liter I'll convert to milliliter, 10 to the power of 3 into 112, right? So if I solve this one I will get 10 to the power of minus 2 Faraday, right? But the question is in terms of Coulomb also, options, right? So we can convert this Faraday to Coulomb. We know 1 Faraday is 965 into 100 coulombs. So we will get 965 and 00, that will be 965 coulombs, right? So answer will be option A. But again, I'll put some other value, oxygen equivalent volume also you should remember. For oxygen, the N factor is 4 because it gains 2 electrons, it releases 2 electrons to get converted to oxide. So we will get 5.6 liter. Okay, so these two values, please keep it in mind. Next question. So this one is, I'll tell, a difficult question, not very easy. We should know the concept of equivalent volume for this question, right? So it is not very simple and direct question. Okay, next question. And this is the last question of this video. Which of the following has the maximum number of unpaired electron? Again from D block question. For this, you must know the electronic configuration of all the compounds, right? From 20 to 30 atomic number, scandium to zinc. Please remember the electronic configuration. Then this question is just a very easy question for you. But if you don't know the electronic configuration, then it is difficult. So what is there? Mg2 plus is there, titanium 3 plus, vanadium 3 plus, Fe2 plus. Okay, let us quickly write down their electronic configuration. Magnesium, atomic number is 12. So we have 1s2, 2s2, 2p6, 2p6, 3s2, right? So next one is your magnesium 2 plus means 2 electrons will go from here. So we will get the electronic configuration 1s2, 2s2, 2p6, right? So you can say there is no unpaired electron, that is number of unpaired electron is 0. Now coming to titanium 3 plus. Atomic number is 22. Electronic configuration is argon 3d2, 4s2, right? Scandium, titanium, argon 3d2, 4s2. This titanium 3 plus, 2 electrons will lose from here, 1 electron will lose from here. So I will have only 3d1. So number of unpaired electron will be 1 here. Now coming to vanadium 3 plus. Again vanadium electronic configuration is 23, that is argon. I am writing the electronic configuration so that you can revise it once again. 4s2, 3d3, right? So if we get that 3 plus, again you have to remove 3 electrons, 2 electrons will go from s orbital and last 1 electron will go from 3d orbital. So what will be my electronic configuration now? Argon 3d2. So number of unpaired electrons here is 2. Now Fe2 plus electronic configuration is what? Fe is your 26 atomic number, argon 3d6 and 4s2, right? So we have to remove 2 electrons, we'll get 3d6 here. Now does it have 6 unpaired electrons then? No, you have to write the configuration. So if you see 3d6, d orbital has d has 5 orbitals. We have 1, 2, 3, 4, 5 and 6. So how many unpaired electrons are there? 4, right? So that is why you can see which of the following has maximum number of unpaired electrons. So undoubtedly it is your option D, right? So that's all for this video. Thank you. I hope you have done it correctly. You have enjoyed the video. And then okay, so here is one WhatsApp channel. Join Diksha KCET WhatsApp channel for all the updates, right? Whatever questions, the mock test, their solutions will be uploaded in this channel. So you have to visit it regularly. It will be helpful and you can get all the updates quickly, right? So please join this channel. It is for your benefit and for your exam. Okay, so finally you can, if you have liked this video and if it is informative for you, please like the video, share it for your friends and with your relatives and subscribe the channel. Okay, thank you so much.